All right, welcome. In this video, we're going to be working through some free response no calculated problems. This is I'm pretty sure this is from the 2008 International Practice Exam. This is numbers 4, 5, and 6. And so we're going to start off here. We've got a graph of a function. It says f of x is log of x times sine of x. And they're giving us the graph of this function for 0 to 2 pi. And g is then antiderivative for f. All right, so find g of 1 and g prime of 1. G of 1. I was like, how am I going to integrate log times sine? I don't think that's one that we did when we did integration by parts, because I don't think it would work that well. But anyway, g of 1 is equal to the integral from 1 to 1 of f of t dt. And we know what that is. That's going to be 0. Okay? G prime of x is going to be f of x. Okay, which means to me that g prime of 1 is going to be f of 1, which is looking like 0 there. Okay. I feel like on this one you would want to definitely be sure to at least say that g prime of 1 is f of 1 to implicitly say, hey, I know that the derivative of g is f. So because if you just said it was 0, I feel like they might be like, are you know, how do you know that? Are you right for the wrong reason? So on what intervals, if any, is g increasing? Okay, well, we just said that g prime of x equals f of x. Okay. G is going to be increasing when g prime of x, which is the same as f of x, is greater than 0. Okay, if you want to say greater than or equal to 0, that's fine too. All right, and so that's going to be between 1 and that's not 3. That's going to be pi, right? Because the sine of pi is 0. So the zeros of f are going to be the zeros of log, which is only x equals 1, and the zeros of sine, which is going to be x equals 0, pi, 2 pi, 3 pi, 4 pi, so on. Okay. And then you see there's going to be another one there too. So it looks like to me it's going to be from 1 to pi. Okay. And that's... C, we're going to run the absolute minimum of g, okay, and then we're going to justify our answer. Think about this. This is not an, okay, this is interesting because it's not a closed interval. It's not open either. But, so really our candidates are going to be x equals 2 pi and all the critical points, okay? Because if if we had to consider 0, then there would be no minimum because the function doesn't exist at 0. So need more discussion on the less than thing, just come talk to me and I'll work with you on it. Anyway, I'm going to say, all right, well, again, going back to the fact that I don't really want to anti-differentiate log of x times sine of x, I don't think I want to take... Okay, it's going to happen at x equals 2 pi. Let me think about this for a second. Find the value of x at which g has an absolute minimum. Okay, because isn't it going to be, yeah, it's the integral from 1 to x. Okay, so what I'm going to say is that g of 1 equals 0 for all x between, between 0 and 1. G is going to be positive because I'm integrating backwards on a negative region. Okay, and then for, say x between 1 and 3, or x between 1 and pi, G is going to be increasing. We already discussed that, and then it's going to decrease a lot over here. And so it's like you're thinking, okay, well, it decreased a little bit, increased, and then decreased a lot. So this got to be where the minimum happens. Okay, so g of 1 equals 0. Okay. G of x is greater than 0 for x between 1 and pi. Okay. G of pi is positive, but that's going to be a relative maximum. I'm going to mention that there's a maximum. This is one of those where I'm not really sure what they're looking for, so I'm going to say a bunch of things that are true and kind of like give them a narrative. Okay, starts off at 0. G of x is positive for x between 1 and pi. G has a maximum at x equals pi because g prime equals f is the reason. Okay. G decreases from x equals pi to x equals 2 pi because g prime equals f is less than 0. Okay. Oh, I forgot to say that is greater than 0 when x is in the interval, let's say, 0 to 1, because f is negative. That's what I was going to say. Okay, it starts off and it's positive, then it goes 0. So nothing to the left of 1 is even a candidate for a minimum. Okay, this is my candidate so far, but I'm going to take a risk here. I'm going to pull up the scoring guidelines for you, but I've kind of like fumbled on this enough. I'm going to say the amount of decrease on pi to 2 pi is greater than the increase on 1 to pi because of the difference in area, which I don't know how. I'm going to think about how to say that. Okay, I'm going to say the amount of area, like the absolute value of the integral from 1 to pi is less than the amount of area there. Okay, I've said a bunch of stuff, but all of it's true. So I'm going to just take a second to go grab the scoring guideline. Okay, even the scoring guidelines are a little bumbling on this one, so I'm not feeling so bad about my response here. It says, for 0 to 2 pi, g prime of x, which is f of x, is 0 when x is equal to 1 and when x is equal to pi. G prime equals f changes from positive to negative only at x equals 1. The absolute minimum must occur at x equals 1 or at the right endpoint, since g of 1 equals 0 and g of 2 pi equals the integral from all of that. Okay, it says by comparison of the two areas, they had a kind of a string of algebra, and you can look it up if you want, but it was more or less equivalent to that. And by comparison of the two areas. Okay, so the points was 3, one for either identifying 1 and 2 pi as the candidates, or indicates that the graph of g decreases, increases, and then decreases. The second point is justifies g of 2 pi is less than g of 1, and 1 point for the answer. Okay, so that one was weird. I won't waste any more of your time with it, though. Is there a value of x at which the graph of g is tangent to the x-axis? That's something I don't think we've talked about in this class. So tangent to the x-axis would look like that, or maybe like that or something. I don't know. That might not be a function, but it's going to be where the derivative is 0 and the value of the function is equal to 0. So I'm looking for where g of x equals 0 and g prime of x equals 0. Well, yeah, we already found one of those points. It was in part A, right? And so that was x equals 1 from part A. Let's make sure there's no other places where this happens. G prime is equal to 0, x equals 1 from A. Well, let's just think about, at x equals pi, that's the other place where g prime, which is f, is equal to 0. And I suppose 2 pi, but we can tell that it's not. There's a difference in areas. This amount is greater than that amount of area. No, it's at x equals pi. Oh, also, no, it's not a comparison of areas because we start integrating at 1. So g of pi is positive. Okay, so I'll just indicate that that's the only place. Explain why or why not. Well, because g of x is equal to 0 and g prime is equal to 0. I already explained why that was true earlier. All right, anyway, let's move on. All right, f prime equals 4x minus 2x f of x for all real numbers x with f of 0 equals 5 and the limit of f equals 2. Interesting. I like where this one's headed, because I think there's probably going to be separation of variables because this is a disguised differential equation. There's an improper integral, which we haven't talked about in a while, and we need to talk about justifying our answers on those. And I think this, Euler's method. That's a good one. All right, so I'm going to decode this for later. And who knows, maybe they're going to, I don't remember this one, if they're going to, write it for you like that when they have you do separation of variables, which has got to be, they translated it for you, but I'm just saying that I could see a world in which they expect you to translate that for yourself. Anyway, let's find an antiderivative for this. Okay. Oh, wait, this is, I was like, oh man, we're going to have to do this one with power rule and this one with integration by parts. But they just told me that f prime of x is equal to 4x minus 2x f of x. So this is actually going to be an easy question, right? Because now they're asking me for the integral from 0 to infinity of f prime of x dx. Okay, so we're going to take an antiderivative. We are not going to plug in infinity like it's a real number. I cannot stress that enough. Okay, I'm going to go in and I'm going to grab the scoring guidelines and I'm going to read to you where they're going to say no points if no limits, basically. And so that's f from 0 to infinity. Now is where I'm going to take the limit as x approaches infinity of f of x minus plug in 0. Okay, 0 is a real number. We can plug that in. Okay, they gave us the limit of f as x went to infinity. That's 2. Minus f of 0, what is f of 0? F of 0 is equal to 5. So this is equal to 2 minus 5. Okay, that's a good one. Okay, Euler's method to approximate f of negative 1 starting at x equals 0 with 2 steps. Okay, so I'm going to go backwards. So I'm just got to be a little more careful. Okay, otherwise, Euler's method, it works the same whether you're going forwards or backwards. So I got first tangent is going to be, okay, my point is 0, 5. dy dx is going to equal, you can't see it, but it's going to be 4x minus 2xy. So 4x is minus 2xy. I hate these Euler method problems where the first one has slope 0. I don't know why, it just makes me so angry. So y minus 5 is equal to 0 times x minus 0. Okay, then I'm going to plug in my first step. That's going to be x equals negative 0.5, and y is going to equal 5 again, because I'm just going to add it over there, and I'm going to multiply 0 by negative half. Okay, now I'm going to write my second tangent. Okay. And I'm going to have a point negative half and 5. My slope is going to be dy dx is equal to, 4x minus 2xy. Okay, so this is, I need to simplify this. This is negative 2 plus 5 is going to be 3. Right, so that's going to be, negative 2 plus, from the two minuses, 1 times 5, yeah. Okay, now my equation is y minus 5 is equal to the slope times x minus negative half. And then we're going to plug in x equals negative 1, and y will equal 5 plus 3 times negative 1 plus a half is negative 0.5. And that'll be my, approximation. So I'm going to conclude, whoops, probably couldn't see that f of negative 1 is about equal to 5 plus 3 times negative 0.5. Not worth the risk on the arithmetic, right? Please don't do that. And now we're going to find the particular solution to the particular solution, which is y equals f of x, to the differential equation that happens to go through 0, 5. Okay, this is one. I know you heard me in class, you heard me probably on a different problem set saying, but this is one that I'm a little concerned about for us this year in 2022. Because we took a practice test, people were not using separation of variables where they were supposed to. And that's very concerning because this comes with a lot of points. Okay, so we got to be able to recognize when they want you to find the particular solution that we got to separate variables. Okay, and separation of variables only happens with multiplication or division. So I'm going to factor out the x. And you know what? Because I'm going to eventually be anti-differentiating x, I might as well factor out the 2 that goes with that x, right? Because otherwise I'm having a 4 minus 2y, and there's, I mean, I'm sure that you're good enough with the chain rule to be able to navigate that difficulty, but you know, let's just factor out the 2x, because I want to anti-differentiate 2x and get x squared, is what I'm saying. Anyway, so I'm left with a 2 minus a y. All right, now I'm going to separate variables. 1 over 2 minus y dy equals 2x dx. I'm going to anti-differentiate both sides. And that'll be the log of the absolute value of 2 minus y. Check for chain rule. Wait a second, I'm going to multiply by -1 for the chain rule, so I'm going to prepare for that. So I get positive 1 over 2 minus y, not negative 1 over 2 minus y. Then I'll anti-differentiate 2x, and I will get x squared and c. All right. Now I'm going to start solving at the y. And I think the first thing I'm going to do is move that over there. Okay. And then I'm going to get rid of the log by taking e to both sides power. And remember that e to the negative x squared plus c is, we could split that apart, is e to the negative x squared times e to the c, and e to the c is just some other constant that we're going to put there. Now I'm going to drop the absolute values. Okay. I'm going to subtract 2. Okay. And then I'm going to solve for y by multiplying by -1. So minus or plus, that's the same as plus or minus c e to the negative x squared. Okay. Do you need to show all these steps? No. Okay. If I'm working this one myself, I'm going to skip some of them because I've done enough of these problems. I know how it's going to play out. Okay. But I just want to be as specific as possible and show you each of the steps. But I'm not done, right? I need to find out my value of c and whether or not this is a plus or if it is a minus. So I'm going to come in here. I'm going to go over here. My initial condition was up here. F of 0 equals 5. Okay, so since f of 0 equals 5, that's going to give me 5 equals 2 plus c e to the 0. Okay, so I know that c needs to be 3, and that's going to be a plus. Right? And now I'm ready to conclude that my particular solution is y equals 2 plus 3 e to the negative x squared, which does have limit 2 as x goes to infinity, which I guess that's a good sign. Okay. Now I'm going to pull up the scoring guidelines. I mean, you're not going to be able to see it. I'm just going to read them to you. All right. 1 point. Okay, this didn't have the harsh note at the bottom like they do with separation variables, where it's like note, and I'm sure this one has it. Yep, note. Oh, it says max 2 out of 5 if no constant of integration on this one, and it doesn't even say it because I'm sure it was the case. 0 out of 5 if no separation of variables. Okay. And on this one, 1 point for separation of variables. That's getting it to this point. 1 point for the antiderivatives, for both of them being right. 1 for the constant of integration, that's plus c. 1 for using the initial condition, so I did in red. And 1 for solves for y correctly. You know, that's that last point there. Okay. The part B was 1 point for doing Euler's method with 2 steps, and 1 for this number, basically, the approximation. Over here, this one is 1 point for use of the fundamental theorem of calculus, that the antiderivative of f prime is f, and the other is that you got your answer from a limiting process. Okay, so I guess if you did f of infinity minus f of 0, you would still get 1 point. I would disagree with that. I think you should lose all the points for plugging in infinity like a real number, but you know, they didn't ask me. So, all right, let's move on to number 6. Okay, g is defined by cosine of 2x minus 1 all divided by x squared for x non-zero. No, clearly. We're going to use L'Hopital's rule to find the value of g of 0. Oh, and the function g is continuous, because like I just said, it wasn't defined at 0, but we're going to make it continuous because evidently it must have a limit. Okay, so we're going to find g of 0 is going to equal the limit as x approaches 0 of cosine of 2x minus 1 over x squared. Okay, now this is going to, not equals, do not say equals 0 over 0. 0 over 0, not a real number. Okay, so it can't be equal to anything. This is going to cosine of 0 is 1 minus 1 over 0 squared, right? Use that arrow, so it's going to 0 over 0. So I'm going to use L'Hopital's rule. Okay, And this is going to equal the limit as x approaches 0 of the ratio of the derivative. So the derivative of cosine is negative sine of 2x. I left some space because I know I'm going to need to multiply by 2 for the chain rule. And then I'm going to subtract 0, because the derivative of 1 is 0, divide by 2x. And then this is going to go to negative 2 times 0, because the sine of 0 is 0, over 2 times 0. So I'm going to use it again. Okay. And then I'm going to say that this is equal to the limit as x approaches 0 of the derivative of this would be negative 4 cosine 2x, when I apply the chain rule, divide by 2. And now this limit is going to be equal to negative 4 times 1, because cosine of 0 is 1, divided by 2. And I'm going to walk away. Okay. Oh, well, no. Hold on. Let's see what they're going with. Okay, yeah, I'm gonna, because we're gonna use the Taylor series for G eventually, I'm going to call that negative 2, because I'm gonna need that. All right, let f be cosine 2x, right? The first 4 non-zero terms and the general term with the Taylor series for f. Oh, gladly. Okay, so this just goes back to the formulas we have to know and then plugging in 2x. So cosine of x is 1 minus x squared over 2 factorial. I meant to leave this just blank, right? So instead of x, I'm just putting in blanks so that I can eventually plug in 2x. 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial minus x to the 6 over 6 factorial. The general term is negative 1 to the n, because that's the 0th term. X to the 2n, whoops, pardon me, meant to just put blank parentheses in there, divided by 2n's factorial. And so when I go to try to write cosine of 2x, filling in with 2x. Okay, and that's going to get me all the credit I need, right? Then I'm going to move on back here, and I'm going to use my answer from part B to write the first 3 non-zero terms and the general term of the Taylor series for G around x equals 0. It's good to write the skeleton, especially if you're not, like if you're just like, I know the Taylor series formula. I spent the time, I put in the work, I memorized it, then you don't need to do this. But if you're ever, if you're just getting to that point, you're putting in the work right now, well, then you should say, all right, a Taylor series for G around x equals 0 is going to start with G of 0. And then it's going to be G prime of 0 divided by 1 factorial times x minus 0 to the first power, plus G double prime of 0 divided by 2 factorial. This is not the thing to do, pardon me. I just realized I should not be doing, well, these are the first 3 non-zero terms in the general term. Wait, x to the 2. G's nth derivative at 0, n factorial, x to the nth power. But I'm just realizing that G is, I can just manipulate my Maclaurin series. I'm just going to take this, I'm going to subtract 1, and then I'm going to divide everything by x squared, which I actually think was on a Maclaurin worksheet I gave you at one point. Okay, so I'm going to take this and, okay, this is true, right? But if you're not sure and you have work that you want to abandon on the free response section, what you need to do is you need to just strike through it. And that's what I'm going to do. Even though I know that this is the first 3 non-zero terms in the general term of the Taylor series for G around x equals 0, this is not my answer, so I'm going to strike through it. Right? Just be very clear with the reader, this is not part of my solution. So don't count it against me if it's wrong. That's what you're saying. All right, so I'm going to say cosine of 2x minus 1 over x squared is going to be equal to, all right, so what's going to happen is, so I'm going to kind of just, okay, so I'm going to lose the 1, and I'll have negative 2x squared, but I'm going to have to divide by x squared. And I'm telling you, if we don't need to, run the interval of convergence for this thing or anything, do we? Okay. If we're not going to just leave it unsimplified, because it's just that's going to be the way to go. Okay, so plus 2x to the 4th over, what's this going to be? X squared times 4 factorial. Okay, then minus 2x taken to the 6th power. I'm dividing every term by x squared, and I've got the 6 factorial. I'm just going to do the exact same thing over here. Negative 1 to the n, 2x to the 2n, divided by x squared, and multiplying by 2n factorial in the denominator. Yeah. Okay. So that's going to be, you know, it's kind of unfortunate. Maybe on the real one it was a booklet and you were able to look, but like flipping back and forth, that's too much. I'm just going to say this is my answer for part C, and I'm not going to go copy it over, so you don't need to watch me copy it. Equals, well, it's what I wrote back there. But on my real exam, I would copy it if I had to, right? Determine whether G has a relative minimum, a relative maximum, or neither. Usually maximum or minimum. But at x equals 0, and I'm going to justify my answer. Okay, I may not, oh yeah, no, because what's going to happen is, yeah, you don't want to take the second derivative of G by hand. Okay. I think this is a situation where you might be benefited by actually going in and simplifying these terms. I thought it wasn't going to be one, but it is. So when I take the negative of 2 and I square 2x, I'm going to get 4x squared. So, hey, look, I am getting that g of 0 is negative 2 for my first term. Okay, plus 16x to the 4 over x to the 2 times 4 factorial. Okay, which is going to be an x to the 2 in the numerator. Okay, so 16 divided by 4 factorial is 16 over 24. All we care about is because, okay, all right, I'm going to say g prime of 0 equals 0. Because no x to the first term in the Taylor polynomial for g at x equals 0. Okay. Then I'm going to say g double prime of 0 is greater than 0 because, look over here, the coefficient of x to the 2 in the Maclaurin series for g is positive. Okay, since g prime is 0 and g double prime is positive, I conclude there is a relative minimum. And that's going to be all for this video. Thanks for watching.